Hi everyone. Here I am going to do topic 15, video number 3. So here I want to talk about a fraction, okay, that if I have, for example, a denominator approaches to 0 or denominator approaches to infinity. Okay, so what should I do? Okay, so I want to just talk about that. Okay, so look at this question. So 10 over x, or any number over x. So x goes to so x is 0 0.1, 0 0.01, 0 0.001. This means x is approaching to 0 from right side. It doesn't mean positive 0. No, it's from right side. When I show plus, okay, that's right side. Oh, okay, so yes, x is approach, and we know it's approaches. Okay, so what's happening here? So 10 divided by that is 10 divided by 1 over 10, so it is 100. 10 divided by 1 over 100, so it is 1000. And 10 divided by this is 10,000. Oh, okay. So I see as I approach to 0, so for example, I use many 0, for example, and then 1, okay, the number is going to be big and big. Okay, so I can say limit 10 over x approaches to 0 from positive side is infinity. Then I tell you, how about if I check from negative side? Okay, how about from negative side? Okay, so limit 10 goes to x, 10 over x, x goes to 0, but instead of x goes to 0 from positive side, negative side. So I use 10 over minus this, which is minus 100. Then I do 10 over minus this, which is minus 1000. And then I do 10 over minus this. No, 20, which is minus 10,000. Let me see. 100,000. Yes, 10,000. Okay, 10,000. So, okay, let me just see something here. Just wanted to check something from the other computer. Yeah. Okay, so minus 10,000 here. I see when I have 10 over x and I have limit and I have x goes to 0 from negative side. Oops. So I have minus infinity. Okay, so from one side positive infinity, from one side negative infinity. Okay, so here I can say something. If I have, let me write it here. If I have limit a over b, b goes to 0, I have different option. It is infinity if a is positive and b goes to 0 from positive side. It is minus infinity. It is again infinity if a is negative, or I can just talk about a positive. Okay, a positive and b goes to 0 from negative side, it's minus infinity. Again infinity if I have a negative, b goes to 0 from negative side. So I have negative, negative, top negative, bottom negative. And I have minus infinity if a is less than 0. Okay, and b approaches to 0 from positive side. Okay, so here I have positive, positive. So here I have negative, positive. Here I have negative, negative. And here I have positive, negative. Okay, so when I have a number divided by something which approaches to 0, okay, so I can say a is a number. A is a number. Yeah, it must be a number. Okay, so if top is a number and denominator approaches to 0, depends on the sign of top and depends on which side b is approaching to 0, from left or right. It's either infinity or minus infinity, so you have to check. Now this is different. This one x approaches to infinity, not like 0, not 0 from like the other one. Oh, okay, so how about this and how about this? X approaches to minus infinity. Oh, okay, so I don't know where is infinity. It's not clear for me. I cannot touch it. So instead of infinity, I use 10, I use 100, I use 1000, I use large numbers. Oh, okay, so what is 10 divided by 10? 1. What is 10 divided by 100? This. What is 10 divided by 1000? 10 divided by 1000. This. Oh, as I approach to a large number, I can see limit 10 over x when x approaches to infinity, approaches to 0. Yeah. See, because my number is going to be smaller and smaller. Okay, so let me also do this. Okay. Yeah, also I show this here. Yeah. Yeah. Yes. Okay, so how about that? So here I can check for x minus 10 and minus 100 and minus 1000. So 10 divided by minus 10, which is minus 1. Okay, so 10 divided by minus 100, which is minus this. And 10 divided by minus 1000, which is minus this. Okay, so I can see when I have x approaches to minus infinity, also 10 over x is approaching to, so limit 10 over x, x goes to minus infinity, is approaching to 0 as well. Now I can tell you when I have number, when I have limit number divided by a and denominator approaches to infinity or minus infinity, infinity or minus infinity, yes, this is 0. I can accept that. So number over something, a very large number or very small number goes to 0. Number over 0 goes to infinity or minus infinity, depends on the sign. And remember, they are in limit. So if you remember, I used to say when I was teaching math 171, I used to say, okay, so sometime I see a student, when they have 0 in the denominator, they say it is infinity. I am sure you remember because I say this many times. So I say, okay, when a student sees 0 in the denominator, they put infinity or minus infinity. because you remember, some of you know calculus and you remember this, but remember this is in limit. When I have limit, so when I have limit, okay, so what's wrong here? Okay, so let me, yeah, when I have limit 10 over x approaches to 0 from negative side, that's minus infinity, and from positive side, infinity. But remember, this is in limit. If I say 10 divided by 0 means denominator is exactly 0, that's undefined. But here is limit. Denominator is not 0, is approaching to 0. So if you remember, I used to say this in Math 171. I used to say, sometimes I see a student when they put 0 in the denominator, they say infinity or minus infinity. No, this is in limit. So 10 divided by exactly 0 is undefined. But 10 divided by x, when x approaches to 0, infinity or minus infinity depends on the sign. Okay? So how about here? So here it's just showing you the direction. But I showed you the direction already. So I showed you x over. So here x goes to 0. Okay? From left. Means from values less than 0. And here x goes to 0 from right. Okay? So from right here. Okay? So I'm just thinking, let me see. I'm just thinking, so for this one. For this question, okay. So how do I ask you? Okay, so for this question, can you answer what is the, for example, what is the answer here? It says it says just find the answer, but can we say it by all the knowledge that we have? Can we say this? Okay, so this is exactly like here. Yes? Okay, I have a number which is positive. Okay? I have a number which is positive. Denominator approaches to 0 from negative side. So this is minus infinity and this one is infinity. How can I prove it? Okay, I start from small values. For example, I start from x equal this, and I check this, and then I check this, and maybe I check this, and maybe I check more digits, more zeros for this one. How about for here? For here I do this one, or I do, and then I do this one, and then I do this one, and then I do this one. Okay, and see the number is getting larger and larger, positive infinity. Okay, so if I give you a question like that, you can talk about it this way. So you can start with some values and then just find that the number is going to be bigger, smaller. Okay, how about this case? For quotient of two polynomials, so that's a new thing. For quotient means division, quotient means the result of division. Okay, so of two polynomials, okay, when the limit approaches to infinity or minus infinity, so top and bottom becomes infinity. I cannot say infinity over infinity is 1. Infinity over minus infinity is minus 1. No, it's not defined, because infinity is not really a clear thing for us. So what should we do in this case? Oh, okay, top and bottom infinity. What should I do? Okay, a more common thing is you have to find, okay, so you have to find something to just divide top and bottom with it. Okay, So what? Okay, so find the highest power of x in the denominator and then divide top and bottom with that thing. Okay, let me show you on one example. When I substitute, I see this is infinity over infinity. Okay, mathematically this is not correct. Mathematically I cannot say 4 multiple infinity power 3 minus 3 multiple infinity power 2. This doesn't make any sense because I cannot touch infinity. It's not clear for me. But I know if I do, okay, infinity cube, so that's a very large number. So even if I do minus 3 infinity squared, it doesn't change the situation. So still it is infinity over infinity. For signs, I look at this. For sign, I look at the largest power. Okay, so yes, it's positive. And I look at x goes to infinity. Okay, so then, okay, so this is not clear. What should I do? I have to divide top and bottom with the highest power in the denominator. What is highest power in the denominator? x3. So x cube is the highest power in the denominator. Oh, okay, so I do limit 4x cube minus 3x squared plus 5 divided by x cubed divided by 5x cubed minus x squared plus 3x divided by x cubed. X goes to infinity. Okay, you don't say I did anything wrong because I divide top and bottom. When I do top and bottom, I didn't change my question. I multiply top and bottom, I didn't change my question. Okay, so okay, so this is limit. Maybe you just want to watch it and then maybe you want to do next example on your own. Okay, so limit 4, okay, x cube over x cube minus 3x squared over x cube plus 5 over x cube divided by 5x cube over x cube minus x squared over x cube plus 3x over x cube. X goes to infinity. Oops. So it is limit 4. I can cancel. Can I? I can cancel here. Okay, so I can cancel this and simplify it. See, if you see infinity over infinity or minus infinity over infinity, for example, you have to divide top and bottom with the highest power you see in the denominator. Then simplify. Okay, so this is 4 minus 3 over x, that's a squared, plus 5 over x cubed over 5 minus 1 over x plus 3 over x squared. X goes to infinity. Okay, do you remember? When x goes to infinity, a number divided by x goes to 0. Do you remember this? When x goes to infinity, look at this. A number divided by infinity, okay, or negative infinity goes to 0. Oh, okay, so this goes to 0, this goes to 0, this goes to 0, this goes to 0. If it was on the paper, you show me this way. But if it is on the computer, so you want to write it, you can say this and this and this and this, yes, they go to 0. And then what is the result? The result is limit 4 over 5, x approaches to infinity, which is 4 over 5. Done. 4 over 5 is the answer. Okay? Oh, perfect. So I find the answer. Okay? So, oops. Let me see. Yeah. How about this one? Again, I substitute and I see it is infinity over infinity. I can do the same thing for minus infinity. Oh, okay. So I divide top and bottom with x cubed, the highest power in the denominator. Oh, okay. So I have limit 4x squared minus 3x plus 5, divided by x cubed divided by 5x cubed minus x squared plus 3x divided by x cubed. Okay, and x goes to infinity, equal, this is limit 4 over x minus 3 over x squared plus 5 over x cubed divided by 5 minus 1 over x plus 3 over x squared. X goes to infinity. What happened when x goes to infinity? This is 0, this is 0, this is 0, this is 0, this is 0. Oh, what is the answer then? The answer is limit 0 over 5 x goes to infinity, which is 0. When I have 0 divided by a number, that's 0. 0, done. No problem. That's a number, done. Next question. Next question, yes, infinity over infinity. I changed the color, I know. Okay, so infinity over infinity. Okay, so I divide top and bottom with x squared. Oops. So it is limit 4x cubed minus 3x squared plus 5 divided by x squared divided by 5x squared minus x plus 3 divided by x squared. X goes to infinity, limit, equal. Yeah. So it is, okay, it is limit 4x cubed over x squared, I do it step by step, minus 3x squared over x squared plus 5 over x squared over 5x squared over x cubed minus 1 over x, this plus this. X goes to infinity. Now I simplify. It is limit x goes to infinity 4x minus 3 plus 5 over x squared divided by 5 over x minus 1 over x plus 3 over x squared. What is the result now? Okay, this is 0, this is 0, this is 0, this is 0. Did I make any mistake here? Let me see. Oh yes, here must be, because I'm thinking, okay, so this is x squared, so I have to, okay, x squared, the x squared, oh yes, that's x squared, I made a mistake here. Okay, and this must be 5, just 5. Okay, so what is the answer? It is limit 4x minus 3 divided by 5, and x approaches to infinity. What is the answer here? The answer here is infinity divided by 5, which is infinity. Infinity divided by a number is infinity, so no problem. It's not, I cannot say it's not clear. Oh, okay, so let's see what's going on here. Zoom out, okay? So, see, when I have top and bottom the same unit, I have top and bottom the same, the same degree. Both of them, the highest degree is 3. Oh, I have a number. When I have top less than bottom, It is 0. The result is 0. Okay? When I calculate. When I have top more than bottom, the result is infinity or minus infinity. Now I can say this. These pictures that I added, they are not by mine. So they are not by me. Okay, so I just found them. I just find them somewhere because I want to make it easier for you to understand. See, if I have n equal m, means the top power, the highest power in the top is equal the highest power in bottom. So it's a number. If I have the top power less than bottom is 0. When I have top more than bottom is infinity or minus infinity. And you saw all of them. You saw all of the examples. We are done by the limit. This is video number 3. I appreciate your time. And the next will be topic 16, 17, 18, which is going to come after the reading. Thank you.